Okay, I think we're just gonna get started. Hopefully people keep getting their Zoom issues sorted out because I had to restart my computer like twice, but yeah. Okay, so welcome back to week 6 of Introduction to Java. And yeah. All right, so does anyone want to name their favorite movie? Anything they've been doing? Anything they're gonna do this weekend? Anything fun? Something big? No? If you're not doing anything, that's always fun. I like weekends just because you don't have to do that much. Okay, so if no one here watches movies, then yeah, let's just get started. Review of what we did last week. Yay. Okay, so what's the keyword for, if you remember any of this, could someone put in the chat like the keyword for bringing in Java libraries if you wanted to use, say, I think last week we used a scanner. So does anyone know the keyword for bringing in these Java libraries in code? If not, that's fine. It's import. So you would say like import java.util something like .scanner, and then you can use the scanner to take in. Yeah, it's input. Okay. So does anyone know what the symbol would be if you wanted to input everything in a library? I think I talked about how you shouldn't do this that often, because usually you want to try to be more specific with what you're bringing in. But then sometimes if you want to just take everything, yeah, it's the multiplication symbol. Someone put it in the chat. Jump. Okay. Actually, give me a second. I forgot to claim host for this meeting. Sorry, just give me a sec. And then okay. And back to what we were talking about. Okay. So yeah, it's the multiplication symbol. Does anyone know if this is the correct line? It's a true or false question. Is this the correct line of code for taking in user input? So you see how we create the scanner object called my object. We do new scanner and then we say system.in inside of that. So does anyone know if this is the correct line of code? This actually would be, I think. I don't think there's anything wrong with it. So what you're doing is, yeah, yes. What you're doing is you input scanner. Yes, yeah, I see that. Okay. You input scanner and then you name it my object. Preferably I like to name it input just to know that I'm like dealing with the user input. And then you pass in system.in. So in Java, you have things called streams. We won't cover what those are really because they're a bit complicated and they're pretty low level. But then, so basically, it's a stream and then the scanner is looking at it and it's seeing like what kind of input there is. And then through the scanner, you can access the user input. So yeah, good job. Oh, oops, I kind of showed the answer if you caught that, but does anyone know what the goal of a try catch is? We also covered this last week. I mean, yeah, you could say that the goal is to try and catch, but more specifically, what is it trying and what is it catching? Yeah, the code, it's trying the code and it's catching for errors. That's good. Bugs, yeah, bugs is also another way to say it. Yeah, so it's to catch errors and to execute code in the case of an error. So it's not only catching the error, it's also running a separate piece of code in the case that there is an error. So we can see that try catch is pretty useful a lot of the time if you're asking the user to give you input, because you never know what the user is actually going to do. The user could try to sabotage the program and just put in something completely off that the program can't use. And then if the user does that, sometimes you would need to try catch to try the code, try the user input, and then if the input is invalid, you catch it and then you execute code. So yeah, good job. And then one more bit of some more questions. Does anyone remember what a switch does? A switch statement? Yes, it switches. But more specifically, like, what is it switching? What does it mean to switch? Code? Yeah, I suppose you could say that. So it compares a value or variable against all of these cases. You have switch, and then you have your expression inside of it. And then you have all these cases. And if the case matches the variable, so if the value is equal to it, then it executes a specific block of code under the case. So it's like I had my variable as number, and then you have all these cases, number, case 1, case 2, case 3, case 4. And then if the number equals to 4, say, then you would have to go, then it goes down to case 4 and it executes the code that's under case 4. So yeah, it switches. That's one way of saying what it does. Does anyone know what keyword is often used at the end of blocks of code in these switch statements? Usually we would use this keyword to stop the code so that it doesn't run the rest of this entire switch statement. It's one word. It's pretty short. Stop is a good guess. I think stop is, I don't think it is the one for Python. Halt. Halt's also a good guess. All of these words basically mean the same thing, but for Java, it's specifically break. So you would say break to stop the code of the case. Yeah, break. Okay, so that concludes what we want to cover for last week. Now, our content this week, it's what this is going to look like. First, we're going to go over some random numbers. They're pretty fun. If you do any like analytical stuff, if you want to try any like statistical things, you would have to use random numbers, and Java has a built-in function for doing that. We're also going to cover do while loops. So it's kind of like a while loop. I was going to cover this along with while loops and for loops, but then I kind of just forgot. So we're going to do while loops. It's like a while loop, but slightly different. We're also going to do some writing to files. So we're going to, that's kind of like putting text onto files. We're also going to do a project, kind of your own piece of code for you to try to implement. And then I'll kind of like walk you through it. So it's going to be more like detailed than just an exercise, but yeah. So those 4 things. And let's get started with random numbers in Java. They're pretty fun. Okay, so random in Java, you have a random library that's going to give you all these random numbers, and it's generating pseudo random numbers. And we'll explain what pseudo random means, but for all like intents and purposes and for practical uses, it is random. You don't know what the output is going to be. So to get this library, to get this package, you want to just say import java.util.random, and then you would need to create an object of type random, and I'll show you what that looks like. So here's an example. So if you look here, we have a object called rand of the type random, and then we do rand.int with a bound. I'll explain what that is. Rand.next double. So if we go through all 3 of these, you see that we have an object of type rand, and then we say rand.next int, which just gives us a random integer. It's any valid integer, so it's extremely big. It could be extremely big, and most of the time it is pretty big because it goes from like negative like 2 billion to positive 2 billion. So the numbers get pretty big, and then we have most of the time you wouldn't want such big numbers, right? So we have dot next int with a parameter. This is it says bound here. This is just my IDE. This is just my Visual Studio Code helping me. And then in your bound, you have bound as 10. So that just means that it would give you a number back from 0 to 9, including 0 to 9. And you also have random.next double, which is I spelled random wrong here, but vadnum. It gives you a double from 0.0 to 1.0. It includes 0, but not 1. So you'll notice a pattern here is that it always includes 0, but not like the upper number. So you see here, the number can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, but it can't be 10, even though 10 is stated as like the bound here. So what it means is that 10 is like the max bound, the upper limit. It can't be 10, but it goes all the way up to 10 from 0. And then you have your next double, which is just 0.0 to 1.0. So yeah, that's how you get random numbers in Java. And what you want to notice about all of these methods, all three of these, is that they return a value. We're not actually doing anything with this. So the code right now is kind of useless. But if you wanted to actually use these random numbers, you would have to store it inside of a variable, and then you would have to, or you have to use it immediately or print it out. And I'll show you examples of all of that in a sec. Okay. So here's an exercise actually. So I want you to just generate a number from 1 to 50, including 50, and then store it in a variable. And then I want you to print it. So if you go back to here, ren.nextInt, that, and then with a 10 inside is just 0 to 9. So if you wanted to print out something from 1 to 50, it's basically the same principle. And then I'll give you about a minute or two to do that, and then I'll show how to do it, because you might not have any idea yet. I'll keep the screen up just so that you know what an example looks like. Do you actually want to show me what your issue with VS Code is? Oh, okay. Do you want to? Okay, so screen share for a sec. Okay, it's fine if you can't, but usually when you see just get started, you have to open up a new file. So you go to the top left here. I'll show you what that looks like. Let me just share my screen. Okay. Oh no. Okay, here. So usually if you get like just get started, you click here in the top left, explore, and then you have to open up a new file. So you can't just. So you have to click up here. You have to click explore, and then you have to open up a new file instead of a folder or something. So it's like, I'll show what that looks like. Yeah, I'll just show you here. Are you on the screen? Is this what you see? Yes. Something along these lines. Get started at the top. Yeah. Okay. So you go to the top left here. You click. You see these two pages. You click on those two pages, and then you should see like open photo or something. Yeah. Do you not get this menu here? Okay, that's fine if you don't. You can just go to file, and then if you don't see the open folder when you click on the pages, you can just go to the top and then you can do open, you can do file. So hover file, and then there should be a menu that pops down, and then you can do open, and then you can just choose like any sort of file or folder to go into and then create a new file. So just click open from the file dropdown, and then you can open like a new Java file. Yeah, that's just like, you just have to navigate your own file explorer. So just like find a new folder or create a new folder. And then, yeah, if you're in downloads, you can honestly just open the downloads folder. I highly recommend you not to, but just either make a new folder or find one that you already have code in, and then make a new file inside of that folder. And then from there, you can write Java. Any folders works. Okay, so I think it's been enough time to generate the random number, and then I'll just show what it looks like. Here. Okay, this is not the screen I wanted. There we go. Okay, so if we wanted a number from, I guess I should have said 0 to 50, because 1 to 50 doesn't actually work because it includes 0, but then that's what we can do. So we can do, you see how to, so for Visual Studio Code, if you just do like, if you just type random and then it's included in like java.util, it'll automatically import it for you. So you actually don't have to write the import line yourself. But yeah, you can simply do, if you just do 50, as we talked about, it only goes from 0 to 49. So currently it should be, it won't put anything out except 0 to 49, but then we can fix that in a sec. So it gives us 11. And then, but if we want to fix that, we can just do add 1 here. So now it goes 1 to 50, because the least number it can give us was 0. If we add 1 to it, the least it can give us is 1. And then the highest is 49. If we just add 1, then it's 50. So we won't see that. It's like we won't see 0 or 50 or 50 or 1 most likely, because it gives us a random number. But then, yeah, we definitely won't see it. But either way, it's generating a random number between 0 and 50. Okay, so we're done with that. We can go back to, also, yeah, you should definitely create a new folder for this class if you want to write code in your own IDE. Up until now, because we're going to cover manipulating files, up until now, it's fine if you use the browser, if you use like some kind of online compiler. But then if you actually want to manipulate files, you would usually have to create a folder, download an IDE, and then write code on your own laptop. So yeah. Okay, and then we're done with that. So does anyone have any idea of how to generate a random number in the range of min to max? So you want the least number that you can get as min, and then the highest number you can get as max. As we saw earlier, we can only get 0 to whatever our max is, but then we want min to not be 0, and so we want to know how that would work. Are there any ideas? If not, I can just show you, because it is not the most intuitive thing. But if you wanted a number between min and max, you would just have to set a min. So here's our min boundary, minimum number possible. Here's our max of 20. And then we generate a new number that is between min and max, and then we add min. So the way this works is this is the length of the range that the number can be in. So from 5 to 20, we can have 15 different numbers that it could be. And then we would also have to add min at the end here to raise that number up. So basically, max is 20, min is 5, max minus min is equal to 15, and then plus 1. So 16, and then you add 5. So basically, you can have between 0 and 15 here, and then if you add 5, it's between 5 and 20, including 20 for this one. If you didn't want to include 20, then you can just take out the plus 1. So that's how that would work. And we can test this, I suppose. So if you wanted to test for yourself how this works, I'll just put the code in the chat, actually. You won't, like I said, for the last one, you won't, it's the same that in that you won't actually see like your min and max values every single time, but ideally it should give you a value that's between the two. Let me try to give you this code. I think I deleted earlier, but here it is. Okay. So yeah, that's the code. And then here's some questions for you. Okay. So does anyone know what the range of possible values would be for num in this first one? You see that we have, that's just the code for getting a value between 5 and 20. So does anyone have any ideas for what the range of possible values would be for this one? You see that next in is 0 to 5, and then it's plus 2. So you're correct that it's 5, but yes, 5 plus 2 is 7. But you're correct that it's 5, and there's 5 possible numbers that this could give you. But what are those numbers? Well, 2 is related to it because the minimum that it could give you is 2. So that's a good guess, actually, but it would actually be from 2 to 7 because you see how that next in, this is from 0 to 5, 0 to 4, I mean. So you add 2, so it's actually 2 to 6, I'd say. Because the first number that it gives you, then that next in, that's from 0 to 5. So you would have it's the possible values that you get from this first part, random dot next int, is 0, 1, 2, 3, 4. So if you just add 2, no matter what the value this first part gives you, it's always going to be between 0 and 6, including 2 and 6, including 2 and 6. So knowing that, does anyone know what the range of values for the second one is? Yep, it's going to be definitely 5 or above, but what's the highest number it could be? It's from 5 to something. 12 is a good guess. But like we said for the above one, it's because it's from 0 to 11. So this first part is 0 to 11. And yeah, 16 is the correct answer. 17 is correct if we had 13 here. Yeah, it's kind of, random numbers are definitely fidgety. It's super unintuitive sometimes because you would expect 5 to be possible here and then 12 to be possible down here. But actually it goes from 0 to 11. So 0 plus 5 is 5, and then 11 plus 5 is 16. So the possible values are from 5 to 16 for this one. So yeah, good job, everybody. And we can actually verify the randomness of this. So the random numbers are only pseudo-random. And what does that mean? It's because the way Java finds these random numbers, computers aren't random, right? It's either on or off. You can't just have a number out of nowhere that you don't know what it's going to be. So the way computers do it is by I think it's like you find some absurdly weird number. Like I've heard that you like find the total amount of time the window's been open, or like the time in milliseconds since a specific date or something, and then using that you mod it, or like you do some kind of operation on it. Basically, it's some obscure method to find a pseudo random number, and that just means that you always know what the random what the number is going to be if you give it the same input each time. So given the same input for seed, you always get the same output. And seed just means that with random numbers, a lot of the time that these numbers are generated, they're given a seed, and then the same seed always gives you the same random numbers. So that also means that they're deterministic, and that just means that for the same input, you're always going to get the same output. If you do math, you can think of it as a function. If you give it an x, it's always going to give you the same y. The same x always gives you the same y, and if it doesn't, then it's not a function, right? So that's what deterministic means. Sorry, and then that's the same way that random numbers in Java works. We can test this out for ourselves in a sec, actually. Actually, yeah, just test it out for yourself. Create the random object with seed 1, and then print out next int a couple times. And ideally, what you should see is that each time you run the program, you want to run it several times, and each time you run it, the output is always going to be the same. You're always going to get the same random numbers in the same order because you're giving it the same seed each time. Give the seed as 1, and then we should all get the same output, ideally. So just try that for yourself, and then I'll show you what it looks like in about a minute. Also, yeah, if you're having a lot of issues with the with Visual Studio Code or any kind of IDE, then like just use the online compiler, and I'll send the link for that in a sec. Yeah, Ddoodle works pretty well. It's a Java compiler, and here it is. Here's the link to it. Okay, so now that you've given a chance to try it for yourself, I will show what it looks like, and here it is. Okay. Here it is, and then you see that when we do the random object, we give it a seed of 1. Here it is, and then we print out rand.nextInt with a bound of 10 3 times, and ideally each time we see the same numbers come in the same order. So let's try it out. So we get 587 here. If we run the code again, 587 again, 587, and you'll see that it's not completely random, but if we change the seed, then it's going to be different. So now the seeds 2, okay, it's not different yet because I didn't save the file, but seeds 2, and now it's 820, and then it's 820 again because I didn't change the seed. So yeah, the same thing works with Minecraft. If you ever played that, the map and terrain is completely randomly generated, but if you ever create a new world, you see that sometimes you get an option to put in a seed, and that's exactly what's happening here. Minecraft's maps and terrain is completely based on random number generation in Java, and it's based on a seed. So yeah, that's just how that works. If you give it the same seed, obviously you're going to get the same map. So okay, good job, guys. Now we can move on. And then also, as you saw, when created without a seed, when we don't give it a specific seed, the outputs of the random class are basically just completely random for all intents and purposes. You won't have to ever worry about it because you never know what output you're actually going to get. Also, the outputs of next int should all have the same probability of occurring, which means that if you have 0 to 10, if the possible values are from 0 to 10, then it means that the number 0 and the number 1, the number 2, all of them should have the same number, the same possibility, the same probability of occurring. We can actually test this for ourselves. So it's pretty cool. If you just do here, I'll just show you. So here's a demonstration of what that looks like. Okay. So here it is. We can code our own simulation for this. Okay, so we take this. I had the code for it here. Okay, so you see here, up here, we create a new random object. And then down here, we create an array, which is something we've already covered. This is an array of size 10. Down here is the number of trials. So the number of random numbers that we generate. And then we have a loop to set everything in the array to 0 from the beginning. So if you commented out all of this stuff, and then you just printed out what the array was down here, you would see that it's supposed to be 0. So let's save that and then let's run it and see what it gives us. So yeah, you see that the entire array is 0.0, but then here's the code that we actually are interested in. We can get rid of this. So here's the code that we're interested in. For the number of trials, each time we can create a completely new random number. So we do random number equals 2. And then we want to set the bound to 10 so that the number is between 0 and 9, including 0 and 9. So here, so it's a random number from 0 to 9, including 0 and 9. And then using that number, we can just say, we can add 1 to each index every single time that we land upon it with the random number. So basically, it's from 0 to 9, and then if it's 0, it'll add 1 to the value contained at 0, which all of these values start at 0. So using that, we can actually see the percentage, the probability of each slot. So here it is. So you see that we had 12 numbers show up to be 0. We had 6 that showed up to be 1. 8 showed up to be 2. 8 of them were 3. 12 of them, and you just see that some of these are above 1. 0.1. Some of these are below 0.1. If all of them, if all of them were the same chances, then you would think that it's 0.1. But this variation is because we only had 100 trials. If we increase the number of trials to say 1,000, or what is this? This is 100,000, and then we test it again. Yeah, we can see that all of these values are a lot closer to actually being 0.1. And the reason that all of these are close to 0.1 is because we have 10 different values that it can be, and all of them have to be have the same probability of occurring. So all of them have a 1/10 chance of occurring, so it's 0.1. So yeah, and if you've taken a statistics course, you can actually calculate the mean and the standard deviation of all of this, and you see that come close to being a normal distribution with the mean being, say, like 5. We can actually calculate the mean here if you're interested in that. Let's have a value called sum, and then we can, at the very end, we can print out sum divided by the number of trials, and then we see what the mean value is for this. I think if we don't have that many trials, then the mean is going to be different from 4.5, but yeah, it's 4.17 with 100 trials, but it should come close to come very close to 4.5 after 100,000. Yeah, exactly. It's 4.5.061. And that's just a pretty cool way you can look at random numbers in Java from a statistical point of view. And then if we set the seed up here to be 1, it gives us the same value each time. So it's 4.499 with all of these values. And then if we run it again, we get 4.499 again, because all of these random numbers that were generated up in here are the same. And I'll put this code in the chat too if you want to test it out for yourself and play around with it. And now back to what we were talking about. Okay. So yeah. Here's an exercise for you to do. I'll give you a few minutes to do this, and then I'll show how to do it. Basically, I just want you guys to try to create a program where the computer outputs either rock, papers, or scissors. So, you're playing the game rock, paper, scissors, shoe. And all 3 outputs should have basically the same probability of occurring, or as much as you can control what the probability is. So basically, you're going to be generating a random number and then using if statements to output either rock, papers, or scissors. And then I'll give you a few minutes for you to do that. The examples are in the chat. Okay, so hopefully that was enough time for you to try something. Did anyone actually implement this and want to show it off, or should I just show how to do it? Okay, if not, then yeah. No, just share my, I'll share my screen and then I'll try to do it. So here it is. And oh, I actually didn't save it, but essentially you just want a random number. And then you would do, and you want it from 0 to, you want 3 possible numbers. So you do the bound of 3. So it's 0, 1, and 2. And then you just say, if you could probably use a switch case here if you wanted to, but I'm going to choose not to because there's only 3 possible solutions with 3 possible values. So if random number is equal to 1, then you do an output of rock, and then if the random number is equal to 2, then you would have it as you could say scissors. Obviously, the order or which one it corresponds to doesn't really matter. And then the last one you can just have as else, because if it's not 1 or 2, it has to be 0, because dude, it would make more sense to just have it as 0, 1. And then the last one has to be 3. I mean 2, because it's 0 to 2. And then you would just output paper. So let's see if this works. Gives you Valk this time. Oh, gives you Valk every single time because I have the seed as 1. But if we delete the seed, then we don't know what seed we're going to get, and it should change. No? Still just, oh, I didn't save it. My bad. Here. Now it should work. Yeah, so now we don't know which one we're going to get. Paper, Valk, paper. Let's try to get a scissor. Yeah, nice. Scissors. So yeah, and all 3 of these have roughly the same chances of occurring. If we made another int array and we wanted to say here size 3, and then we did this a number of times, and then we added it to the array and found the distribution, it would once again be normally distributed, which just means that all of them have the same probability of occurring. They should all be 1/3 or close to 1/3, because it's not completely accurate. The only way to get complete truly 1/3 is to have an infinite number of tries. But yeah, so hopefully that made sense. Let's move on to the next part. Oh yeah, so now we're doing a do while. Okay, so essentially a do while loop is a while loop, except the code inside is always going to run at least once. So you see the code up here, do, the code in here is always going to run at least once before the loop ends. And then while down here inside the parentheses, there should be a conditional. And if it's true, then the loop keeps going. And you see that this one is, well, this one is actually an infinite loop because you just say true. Definitely don't ever do this. Don't ever do while true, or try not to. There are some occasions where you might want to, but so yeah, this is an infinite loop, and the code inside do always executes first at least once. So here's an example of what you might want to use a do while loop for. So this is a do while loop that asks for a password until you get it correctly, or until you tried more than 10 times. So you could see how this is simpler than just doing a while loop, because if you wanted to have a while loop, you would have to ask for a password first, and then you would have to update it every single time it goes. And here, you just have to ask for it once in the beginning, and then every single time the loop runs, it asks for the password again. And also tries is getting added to. So you see down here in while, this is the conditional that we have. We have tries is less than or equal to 10, and password is not equal to password. So if you start from the beginning, you instantiate tries as 1. You initialize it as 1. That's the value of tries, and then you make a new scanner. That's how if you remember from last week, this is how we get user input. And then we have a string password. This is just a placeholder so that the code knows that it's like a thing. And then you set password to a new input each time you're asking for a password. And then you add on to tries every single time that you ask. So yeah, this is a pretty interesting way of doing it. And I can show you an example of it here. I think I have it saved. Do I? Hopefully. Okay, yeah, it's right here. I'm just showing the screen. Here we go. Sorry, I had to comment this code out. This is for later stuff. And then this is the stats analysis that we did earlier. But here it is. If we just say tries, a new scanner, password, you ask for password each time, and then if it's equal to password, then we stop. So we can just run this and see if it works. Oh, oops, about to save it. Okay, so this should work. Let's see, if we just do some completely random strings, it's not going to ever work. And then if you wanted to see it stop, I think it should stop after 10 tries. Is it not doing that? Oh, it's actually not stopping, but if we type in password, then it stops because that's the correct input. So if you wanted to test out why it's not stopping, let's just debug this together. I don't know why it's not stopping after I've tried so many times. Here. Okay, so we enter a input. That's the first try, second try, third try, 6, 7, 8, 9, 10. Okay, now it stops. I don't know why I didn't earlier, but yeah. So if you ever have your code not working for some reason, like there's a logical issue like we did just now, you can just type in a button. You can just type if statements, to be honest, to debug it. And this should stop. Yeah, now it stops. Okay. Not quite sure why it didn't work. But yeah, that's how you create something that checks for the password. Okay, so let's try to combine this with java.util.random. So try to create a program that prints out a random number from randomly generated number between 1 and 6 until the number equals to 5. So for this one, you would need a do while loop, or you could just have a while loop, but then you would have to do some extra coding. And your program should print out 5 exactly once. It should print out 5, check whether or not it's equal to 5, and then once it is, it stops. And for this one, you're gonna need, like I said, a do while loop as well as the random. You're not gonna need a scanner or user input for this one, but yeah, I'll give you a few minutes to try it out. Okay, so hopefully that was enough time for you to try it for yourself. I'll show what it looks like right now. Okay, so we can basically just reuse the same code that we just had with printing out with the password. Okay, okay, what did I ask you guys to do again? It's between 1 and 6 until it's 5. Okay, that's pretty simple. And here instead of scanner, we just have a random, and then we do and here we say int random number. The reason that we have to initiate it here, we have to create the variable here instead of in here is because once this part ends, then the while loop doesn't actually know what random number is. So we can't just create it in here during the do part. And then here we can just say random number is equal to we can say it's 6, and then it stops. It stops when the random number is equal to 5. And just to show ourselves that it's actually working, we can just print out the random number. And this should work. Okay. It just prints out 2. Okay. Oh, that's because it's while it's equal to 5, not while it's not equal to 5. Now it should stop only when it's 5. Okay. Yeah, if you want to look here, it goes 4, 2, 2, 0, 1, 3, 2, 3, 0, 3, 2, 1, 5. We kind of got unlucky here. It goes through basically every single number before it gets to 5. If we want to run it again, I don't think it should. Never mind. We still get no, it's the different string actually. We're just unlucky both times. Let's try to get a 5 early on. Nice. We got a 5 on the fourth one. Okay. So yeah, 2, 3, 4, 3, 5. As you can see, each time it's different because we don't know what seed. We didn't give it a seed. If we give it a seed, then it would be the same each time. So that's how that works. And then let's go back to the PowerPoint. Okay, now we get to the last part of today, reading and writing from files. So this is like file manipulation stuff. So file manipulation is kind of a basic part of any coding language. There's a lot of jobs that center around file manipulation, and it kind of gives you a new option for taking in input as well as giving output. It also uses the java.io library. So that just means that we're no longer using java.util to use files and functions related to files. We would have to use java.io. And also file manipulation only works when you have an IDE on your computer. So an online compiler won't work for this one. And for that reason, I don't think I'll be asking you to do too many exercises based on file manipulation, just in case that you still haven't figured out how your IDE works. So yeah. So creating a new file, first, we have to create a file object with the name of the file as the parameter. So you see here, we have an object called my object equals to file. And then in here, we do the file name .txt. .txt is just like the tag for whatever, for a text file, I'm pretty sure, like a basic text file that you can open up and edit in Notepad. It's not a Word doc, I don't believe. Actually, Word docs might also be .txt, I don't remember. But yeah, so you see here that this is how you create a new file. It's .create new file. And .create new file returns true if the file was successfully created and false if it already exists. So that's why you see here is an if statement, because create file returns to you a Boolean. And then if it's true, then we can say the file was created, and then you can say the file name. So file created, and then you append the file name. My object.get name is also, it should return file name.txt. It's another method that you can use with files. And then down here, if it gives you false, we know that the file already exists. So we can just print out file already exists. So yeah, Also, one important thing is that when you're working with files, you do have to warn the computer that the file might throw an IO exception. So up here, you see, I'll show you in the code, but here on the line where we declare the main function, we have to say throws IO exception. So if you remember from down up here, we use the java.io library, and then here we're warning that the computer might throw an IO exception. And it's just meaning that if there's something wrong with the way that we access the file, anything we have to do with files, they can all throw IO exceptions. So that's what this is doing. Okay, I'll actually show you what it looks like inside of the code, because I want you guys to see where it throws it. Here, okay. So as you can see up here, it says throws IO exception. Let me uncomment this part and then comment out everything above. Okay. This is the code we used for creating a file. And then we see that if my object.new file, so we create a new file, file name.txt, and then we say its file already exists and file created. So we can actually run this. We can test it for ourselves and create a new file. It's actually pretty cool. We save this, let's create a new file. Yeah, so now it says file created, file name.txt, and look, it's up here. So we created it inside the same folder that the code is in. We can type in it, it's a .txt file. So that means that I can also open it up with Notepad or any kind of like text editing tool. I'm not sure I can use Word, but there it is, file name.txt. And then what's actually pretty cool about this is that because we already have the file here, if we run the code again, it doesn't destroy the file, it just says file already exists. So there you go, file name.txt. So now we can go back to our PowerPoint. Okay. Now, how would we want to write to files? So you saw that I put hi in that file by myself. I did it manually. I had to open up the IDE and then type into it. But if we wanted to use the code to write into the file, how could we do that? Well, we have to use something called a file writer, and it's not the same as the file object. It's a new object that's specifically meant for editing the text inside of a text file. And then, so writing to files can be accomplished with file writer, and you always have to use file writer's .write method, and then always close it after you're done. So here it is. We create a new object called writer to let us know what we're doing in this object. It's a file writer, and then we give it the name of the file that we want to write into. And then we also write into it with this message. We give it a message to put. It says I can now write into this file, and then we do .close. Okay, and you can't forget that if this file doesn't exist yet, it's going to throw an IO exception. So let me show you what that looks like. Here it is. So here's the code. I'll give you guys a second to look at it. So we create the file up here, file name.txt, and the file is already over here. And then we want to write into it. I can now write into this file. And let me just add like a new line up here. Okay. So this should work. I don't think there should be any issues with this. Okay, yeah, so it prints out file already exists up here, but that's because we tried to create it again. But if we actually go up here, there, now you can see it. I can now write into this file. Boom, there it is. So that's pretty cool. And then if we wanted to change this, there we go. And then we run it again. The file exists already, but then we go here and then we have new input. We have new output that we just put into the file. And what's interesting is that if we delete this, so let's delete this file, and then we comment this piece of code out. So we don't ever make the file, then we can watch what happens. So what happens is it actually just makes the file for you. So this is what file writer does. If it senses that there's no file, then it just makes a new one and then it writes to it. So it actually doesn't give you an exception. I thought it did for a second, but so yeah, it doesn't actually give you an exception, and that's pretty cool. I think it actually creates it if it doesn't exist. Interesting. But yeah, that's how that works. And don't forget to close it. If you don't do .close, I think it gives you an issue. Maybe. Yeah, it says it's never closed, and then let's just run the code and see what happens. So yeah, it doesn't actually, nothing shows up here because we never closed it. But now that we close it, the output that we want to give it shows up. And it still doesn't. Let me try it again. Did I break it? I'm not sure how. Yeah, oh, there it is. I think it was just because I didn't update the page, but yeah. So now that we closed it, actually works. Okay, so that's great. There's a lot of other file functionality actually, and here it is. So we can actually read input from a file. We can use the scanner. If you remember, we also use this for user input, but scanner actually is very versatile. You can use it for a lot of stuff. So here we're using it to read the input from a file instead of the system.in. So we have a new file called mySecondObject, and then we give it the file name, or we also do scanner, and then we have to give the file to the scanner for the scanner to look through it. If you imagine it like an actual scanner that you're scanning the lines with, if you're scanning a QR code, you can imagine this as a tool to read the file. It's not the file itself, it's kind of just a tool to look at it. And then we see a while loop down here. And inside of the while loop, we do data equals to next line, and then it prints out the data. So without the while loop, next line would actually throw an error if the file had no more lines. So we'll show you what that looks like in a sec. And I'll demonstrate this actually. It's pretty cool. So here it is. Okay. Down here, we have our code for looking at the file. And then, but before we use this, we obviously want there to be like actual text in the file. So let's just put my name is Yanda, what is, okay, so that should work. Let's save that, and then let's see if this works. It only prints out hello world. I'm guessing it's because it's weird about here. Let me just close this and then here. Hopefully this should work. Still does not. Oh, I don't think I saved it. Here. Now this should work. No, still no. What is the issue here? Is it because, oh, it's because I'm resetting it with each time. Up here when I do .write, it actually wipes the file and only puts in the line hello world. So now that we have that gone, this should, so I did save it earlier, I just like wiped it again. So let's save this. And then now this should print out the lines that we have in the file. Yeah, there we go. Okay, so that you see how we got the lines from here to come to here, and then we printed them out. So that's pretty cool. Actually, before I close out of that, I want to show you what it does if we don't have a while loop here. So up here, if there's no while loop, or if the while loop doesn't depend on whether or not there's a next line, we can just delete it and say, here, let me delete this. Let's just say true. Like I said, never do this. Don't just say true. But here's what it does. So it goes to the lines, goes to the first one, second one, third one, fourth one, And then there's an exception. There's no file found, no line found, because there's no more lines left in this text file for the scanner to look at. And because of that, it throws an exception. And the way that we can avoid that is we just have it stop looking at the lines before the file, the lines went out. So we can do has next line. So this is a Boolean, whether or not it has a next line. If it doesn't, then it stops. So that should prevent the issue. Yep, it stops before it runs into this. So yeah. That is reading from files for you. And then, okay, the last part of today's session is a project. This doesn't include reading or writing from files at all. So you can actually do this in the online editor, the online compiler. And what we're doing here is just creating a game that rolls dice. And on each roll, the player attempts to guess what the outcome is. If the player guesses it correctly, then the game ends. And the score is how many guesses it took for the player to guess the number correctly. A lower score is obviously better in this case. It's kind of like golf. So let's split this up into like manageable steps for everyone to achieve. So I'll give you a few minutes to implement step one, which is just get a way to get input with scanner and then create a new random object called random. So here for this one, we're going to have to use both user input and a random object. So I'll give you about a minute and then I'll show how to do that. And then we'll go to step two. Okay, so this step is pretty simple. I'll actually show what it looks like. I should have given you more on the first step, but here. Let's create a new one actually. Let's do dice. I already have the entire dice game coded, so I don't want to show you that just yet, but here's the dice game. And then we say scanner input. Okay, from there we can say a new random object is equal to new random, and then and then we're gonna need a do while loop. So I just set that up before we move on to step two, and also I'll say true inside of here for now. But also because we know that it depends on the user's guess, we're going to have a string called guess. We're not going to put anything inside of it. And we're also going to, I'll just give you the step. We're also going to need a new integer called guess as integer. And this is going to be integer. We've never done this before, but it's going to be integer dot post int and then guess. Okay, so I'll give you a second to look at it. And the reason that we have to do this Okay, so the reason that we have to do this is because we can't just compare a string to an integer. So we actually have to convert our guess into an integer, and then from there we can say we can say, is the guess equal to the random number that I'm generating? Okay, so I'll put this code in the chat for now if you want to use it when you're trying it yourself. And then I'll show you what step 2 is, and hopefully you guys can finish the game on your own with that. If not, I'll show it at the very end, just before class ends. Okay, here, let me go back to. So this is what the code for the initial setup looks like. And then step 2, so this is what step 2 is, have a do while loop that takes in user input. We've already set up the do while loop. You just need to now put inside the do some way of getting the user to give you a line of input. And then the do while will continue again until the user input equals a random number from 1 to 6. So you're going to have to generate a random number somewhere, and then you're going to compare it against the user input. I've already shown you that you need to convert the user input into an integer, so definitely do that before you compare it. And then the random number will be newly generated each time the while loop runs. So make sure that the random number changes each time so that the user is basically just completely guessing. Also, try to keep track of how many times the loop goes, and so you know how many times it took for you to guess it. So yeah, I'll give a few minutes and then I'll show how this works. Okay, hopefully that was enough time for you to try it yourself. And now that time is kind of running out. I'll just show how to do it. Okay. So with this, we have our guesses. We now want to get the user's guess. So we can say the guess equals to input dot next line. So we can just get a next line of input from the user. And then while the guess as an integer does not equal to the random number that we generate, which is going to be next int and then bound of 6. I think we said 6. Yeah. So I mean, we said 1 to 6, so we can just add 1 to here, I guess. So as long as the integer the user's guessing is not equal to somewhere between 1 and 6, including that 2 ends, then it's going to keep asking the user to guess. And here, we can also just keep track of how many guesses there were in total. So we want to say guess numbers, and then here. So now we print out the guess numbers. Don't forget to also add 1 to guess numbers each time he guesses, the user guesses. And now we can test this out for ourselves and hopefully it works. Let's see. So 3 doesn't work. Oh, 3 was the right answer. Okay. Well, I guess I got lucky the first time. So 3 again. Does it just give am I like stupidly lucky, or is it the code's issue? Okay, yeah, I'm just stupidly lucky the first 2 times. So now it's 3, we guess 3 again, it doesn't work. Oh, it was 2 the third time. Well, I guess I'm getting lucky today. So we're done with that. And that concludes today's session. And yeah, that's the end of session number 6. I hope I see you all in session number 7 next week. Good night, everybody.